السلام عليكم ورحمة الله وبركاته. Today we're going to be beginning with geometric distribution. Now, geometric distributions and binomial distributions I shouldn't be saying that they're the same, but you know, if you understand binomial distributions, then geometric distribution is way easier than that, right? It's way easier than that. And how come? No. So obviously, in our distribution series, the very first thing that we learn about anything are conditions. I will just, change this. Okay, conditions, right? So, binomial distribution is now. Look, let's just revise a bit. Binomial distribution is used when you're trying to do this. You are repeating an experiment a certain number of times, right? You're repeating the experiment a certain number of times, but okay, I'm sorry, my bad. So you in binomial distribution, it's just that you're repeating an experiment a certain number of times, right? And you're just going to try to find the probability of a certain number of successes appearing in that number of tries, right? However, in geometric distribution, you just try to find you keep on repeating an experiment, right? until until the first success occurs. So in binomial distribution, you could have more successes, and in geometric distribution, you could have lesser. You could have only one success, right? Like you keep on repeating an experiment, the moment you find yourself the very first success, the experiment is over, right? So it's like a geometric distribution is always going to be applied in a situation uh, like this: repeating an experiment until first success happens, right? So the moment you get your first success, and you stop the experiment, in that kind of experiment, you can use geometric distribution, right? This is the scenario in which, the geometric distributions are applied, right? Another thing about them is the fact that if I was to give you examples, throwing a dice until a six is obtained, right? Or keeping on tossing a coin until a head is obtained. Like examples of this would be rolling a dice multiple times until a six is obtained, or any number is obtained, right? Or another example of this could be, tossing a coin multiple times, again multiple times, until a heads is obtained, right? That can be one of the examples as well, right? Now the conditions for this is, every time you look at a question, right? You know what, the best part about geometric distribution is that you won't have to struggle way too much. You won't have to do quite a lot of brainstorming, staring at a question only to figure out whether it's a binomial distribution question or a geometric distribution question. Well, obviously, in your very first few questions, you are going to have to figure stuff out a bit, right? Because things take time to fall into place, right? But once you get the hang of it, it's just going to be easy. And geometric distribution is just the kind of thing that if you look at a geometric distribution question, you're just going to know it, like right away. Literally, right away, you're going to know it. Now, the conditions are, okay, so the conditions, well, obviously, the very first condition is repetition, right? Repetition. The experiment is going to be repeated. It's going to be a repeated experiment. You know what? I should try to be working on my writing. Repeated experiment, right? And now again, the second condition is the concept of success and failure must be there. So the concept of success and failure must be there. That is another condition, right? Like I said, geometric and binomial distributions are very, very, very similar, just with a few subtle differences, which makes it, I personally think, which makes it way, easier than binomial distribution. And look, some of the conditions do coincide. Repeated distribution, sorry, binomial distribution was also, it also had to be an experiment that was repeated, right? Success and failure, that was a condition we learned for binomial distribution as well, right? And then the third is also same, which is discrete outcomes. I'm not going to be explaining these conditions because we've already talked about them when we were learning about binomial distribution, right? So that's it, right? Obviously, so success and failure means you're going to have yourself a T and you're going to have yourself a Q as well, right? And Q is going to be equal to 1 minus P, right? That is another thing. Now, the last thing for this lecture is that yes, you're not going to have a value for n. Unlike binomial distribution, there is no value for n, because look, in binomial distribution, you know how many times an experiment is being repeated. In geometric distribution, that is not the case, right? If I am rolling a dice, I don't know how many times I'm going to roll it until I get the first six, right? I may get it on the very first throw, I may get it on the sixth throw, I may get it on the 10th throw, I may have to roll my dice 100 times before I get my first six, right? That can happen too. The probability is there, So I don't know on which try am I going to get my desired outcome. So you don't know the value for n, unlike binomial distribution. You don't know how many times an experiment is going to be repeated. That was it for today's lecture, and tomorrow we're going to do more on that. We're going to start doing some questions and the formula too.